Okay, next we're going to look at the second derivative test for local extrema. We're still going to start by finding where f prime is equal to 0. We're still looking for critical points, but we're really only looking where it's equal to 0. We're not worried about where it does not exist. Now, if it's equal to 0, we'll then check the sign of f double prime at that x. If we're getting a positive value, that means that we're concave up. And if our first derivative is 0, means we have a horizontal tangent at that point, which means this must be a minimum. If f double prime is negative, that means we're concave down, and again that horizontal tangent line at that point would tell us this has to be a maximum value. So there's three tests we have right now for extrema. The first one is checking the y values. We would first find where f prime is equal to 0 or does not exist. But then we would check each of those critical points and the endpoints at find which y values are the greatest. If we need to know the endpoints and we want to know absolute maximums or minimums, we'll need to check the y values. The second one is probably the one that we use the most, the first derivative test. Again, we will look at where f prime is equal to 0 does not exist, but then we would make a sign chart checking if between those critical points, if we're positive or negative, we're looking for the sign changes to decide if they're maximums and minimums. The advantage with the second derivative test is I would just look where f prime is equal to 0, and then at each one of those critical points I would then go and check f double prime, and if I'm getting a positive or negative value, then I would know that it's a maximum or minimum. So using the second derivative test, so I would start by taking my derivative and I would set it equal to 0. This would give me zeros at positive and negative 2. Now these are giving me 0 for my first derivative, so if I look at my second derivative, then I could plug these x values into that. Now I'm not as concerned about the number as simply the sign is what I'm worried about. And so I know here I'm getting negative value, here I'm getting a positive value. That tells me, since this is concave down, that this x equals negative 2 would have to be a maximum value, and since this one's concave up, this would have to be a minimum value. Now in our next example, we're going to use f prime and f double prime to graph f. So we're only given a function for f prime here. So we're going to start by identifying where the extrema occur. Now we'll start doing that by finding our critical points. So we'll set this equal to 0. And be careful that we factor out the x's and not just divide by them. And that's going to give us x equals 0 and 3. So in this, they've split those intervals, so we're looking at 0 here and 3 here. And what's important here is looking at the sign of f. So coming back up to this function, they're going to plug in a value less than that, between that, and so on, and to find the sign of f in each one of those intervals. And so everything less than 0 is going to give us a negative sign. Everything greater than that's going to give, or between there is going to give us negative, and then a positive, which is telling us that we're going down, down, and then positive. And so that would also give us the intervals where we're increasing or decreasing right up here. Now if we want to find where it's concave up or concave down, we'll look at its second derivative. Again, we'll set that equal to 0, and we'll end up with 12x times x minus 2, which will give us x equals 0 and x equals 2. We'll use that to create our intervals, and then we'll check the sign of f double prime in each one of those intervals by plugging in values into our original f double prime up here. We want to look for our behavior then. Basically we're saying we're concave up, concave down, concave up. And then we sketch a possible graph for that. Now notice what we've done here. We've combined the two charts on the last two pages. So here's our sign chart for f prime, which told us about decreasing or increasing, and we've combined that with our chart here, which tells us about concave up or concave down. So our important points are at 0 and at 2 and at 3, and we should look what's happening in each one of those. So notice that we are decreasing, we're still decreasing, we're still decreasing, and then we're increasing. So in the first part we're going down, but we are curving up. In the second part we're going down, but we're concave down. In the next part we're still decreasing, but we're starting to curve back up until we get to 3, and then we're going up again. So that gives us a general shape, even though we don't have a starting point. that we need to be coming down, leveling out at 0, then curving down until we get to 2. We continue to go down, but we're now concave up until we get to 3 as another horizontal tangent, and then we're going back up again. Okay, in this next one we're going to be looking at graphing a function f from its derivative here, f prime. We're going to add in what we know about the second derivative in this. Looking at the second derivative, we're going to notice that until we get here to -2, it's negative, which is telling us our function is concave down. From -2 to 0, we're increasing, which is telling us we're concave up. Now, from here to here, we're also increasing, so again, it's concave up, but there's something happening here that we should be aware of. And then from here to here, our second derivative, since they have a slope of 0, would be 0. There's no concavity there. Basically, that means that we're dealing with a straight line. Now, if we're going to sketch a possible graph of f, then we're also going to look at what f prime is doing. So if we look here, our zeros are at -3 and -1. Before that we're positive, then negative, and then positive again. We've got another 0 here at 1, where before that we're negative and after that we're positive. Okay, so these are giving us areas of increasing and decreasing. And then after 2 here, we have a constant slope of -2. Okay, remember we said that this 0 here told us linear. Now we know exactly what the slope is. Now we're not given a starting point on this one, so I'm just going to start kind of a random spot. We know that we're going up, but we are concave down. And when we get to 3, we should have a horizontal tangent line. Notice at that point we are still concave down until we get to -2 right here. And that's where we have a change in concavity. We're still going down, but now we're curving up, and we have a 0 tangent at -1. We now change after -1. F prime is positive, which means we are going up, and we are also still concave up. At this point, our slope changes from being positive to being negative. However, we're still concave up, so what this is going to look like is a corner like this. Notice at 1 then we have another 0 for f prime, which means we're leveling out. We're still increasing here. Our second derivative is still positive, so we're still concave up. And then when we get to 2, we have a jump here. Okay, so we're now at a slope of 1, but suddenly have a slope of -2, and this is going to be linear at this point. It's going to be a straight line with a slope of -2, something like that. So in summary, we can look at the graphs of f prime and see everything we need to know about the graph of f, and part of that will be considering our second derivative. So first, just looking at our first derivative, if it's differentiable, we'll have a nice smooth curve here. If we look at our first derivative tests, then it will tell us whether we're increasing or decreasing based on whether our first derivative is positive or negative. When we start looking at our second derivative, this is going to tell us about concavity, curving up, curving down when it's negative, or when we get a sign change, probably where y double prime is equal to 0 if we get a sign change, but it doesn't have to be 0 if it's a vertical tangent. We can also find maximums and minimums by looking at sign changes. So this is looking at sign changes of our first derivative, so positive to negative, it's a maximum, negative to positive, it's a minimum. But we can also look at the second derivative. If we look at the sign of the second derivative at a critical point, then we can decide if it's a maximum or minimum. If we're concave down, so our second derivative is negative, we know it's a maximum, and if it's positive, it's curving up, we know that it's a minimum.